Imagine you are using your computer and the computer suddenly glitched by itself. Or you were traveling on a plane and the plane suddenly lose its control and started going down. What would you think of it? Is it a normal problem because these things keep happening all the time? Or there are other reasons behind it? Recently, scientists have discovered some sort of computer errors happen time to time, and that are not man-made problem, but these happen because of the radiation of atoms. These events made scientists realize that space or universe is not hostile for computers, meaning computers won't fully work if we try to use in space. In this video, we will know about what will happen if we try to use computer in space. In 1978, Intel reported some strange errors popping up in their 16-bit dynamic random access memory or DRAM. The error was, ones would spontaneously flip to zeros with no apparent cause. To elaborate, 0 and 1 is called binary numbers, and this number system is used to program computer systems. The problem turned out to be the ceramic packaging the chip was encased in, with the demand for semiconductor packaging skyrocketing. Again, in the 1970s, a new manufacturing plant was constructed on the Green River in Colorado. Unfortunately, this site happened to be just downstream of an old uranium mill. Radioactive atoms made their way into the river and then into the ceramic packaging for Intel's microchips. Scientists investigating the problem found that even trace amounts of uranium and thorium in the ceramic were sufficient to cause problems in their DRAM memory was stored as the presence or absence of electrons. In a semiconductor, the alpha particles emitted by uranium and thorium were energetic and ionizing enough to create electron-hole pairs in the silicon. If an alpha particle struck in just the right place, it could create a large number of free charge carriers, causing electrons to accumulate in the well. Flipping a 1 to a 0, this is known as a single event upset, a type of soft error. The error is soft because the device hasn't been damaged, the bit has changed, but you could erase it and rewrite it with no problems. A soft error is an issue that causes a temporary condition in RAM that alters stored data in an unintended way. Errors that change data stored in RAM are either soft errors or hard errors, which result from a hardware failure. Soft errors can be further divided into chip-level errors and system-level errors. Investigators exposed the chips to alpha emitters with different levels of activity, and just as you'd expect, they found the number of bit flips directly correlated with the number of alpha particles the chip had been exposed to. The reason this problem was identified in the 1970s was because chip components have been miniaturized to the point where a single alpha particle could produce enough charge to flip a bit immediately. These findings attracted a lot of attention before the paper was published. It was widely circulated in the industry, and as a result, chip manufacturers were a lot more careful to avoid radioactive materials when producing their microchips and packaging. Therefore, the bit flip that gave Maria Vindividual 4096 extra votes wasn't caused by natural radioactivity in the computer. So, where did it come from? After Henry Becquerel discovered radioactivity with uranium in 1896, scientists sought a way to measure it. How radioactive were different materials, and one way to do this is with a gold leaf electrometer. When it's charged, the leaf is repelled, and you can measure the amount of charge by the angle of the leaf. Now, if ionizing radiation enters the chamber, it rips electrons off air molecules, creating positive and negative charges. Opposite charges are attracted to the leaf, discharging it over time. The higher the level of ionizing radiation, the faster the device discharges. To know further, let's see what radioactivity is and how does it cause. As its name implies, radioactivity is the act of emitting radiation spontaneously. This is done by an atomic nucleus that, for some reason, is unstable. It wants to give up some energy in order to shift to a more stable configuration. During the first half of the 20th century, much of modern physics was devoted to exploring why this happens, with the result that nuclear decay was fairly well understood by 1960. Too many neutrons in a nucleus lead it to emit a negative beta particle, which changes one of the neutrons into a proton. Too many protons in a nucleus lead it to emit a positron, meaning positively charged electron, changing a proton into a neutron. Too much energy leads a nucleus to emit a gamma ray, which discards great energy without changing any of the particles in the nucleus. Too much mass leads a nucleus to emit an alpha particle, discarding 4 heavy particles which contains 2 protons and 2 neutrons. In 1910, Theodore Wolff took his electrometer to the top of the Eiffel Tower. Since radioactivity was found in the soil and rocks of Earth, he expected that 300 meters up the radiation would be just a few % of the ground radiation. Instead, he found only a slight decrease. An Austrian physicist, Victor Hess, decided to take this experiment further, and literally he loaded electroscopes into the basket of a hydrogen balloon. In his first 2 flights, he observed the same thing as Wolff up to an altitude of 1100 meters. Both trips revealed no fundamental change in radiation compared to the values observed on the ground. But the next year, he conducted 7 balloon flights up to an altitude of 5,200 meters, and here he discovered something remarkable. While there was an initial drop in radiation for the first several hundred meters above 1 kilometer or so, the level increased with increasing altitude. At his maximum height, the level of radiation was several times greater than it was on the ground. The radiation appeared to be coming not from the Earth but from the sky. Hess scheduled one of his balloon flights during a solar eclipse, and as the moon passed in front of the sun, he carefully watched his instruments, but the readings were unaffected. Even with the sun half covered, the level of radiation was the same, since no influence of the eclipse on the penetrating radiation was noted. They concluded that even if a part of the radiation should be of cosmic origin, it hardly emanates from the sun. Scientists have discovered that thousands of cosmic rays enter in Earth daily. It can't be seen in naked eyes. Cosmic ray, a high-speed particle, either an atomic nucleus or an electron, those travels through space. Most of these particles come from sources within the Milky Way galaxy and are known as galactic cosmic rays. Cosmic rays are atom fragments that rain down on the Earth from outside of the solar system. They blaze at the speed of light and have been blamed for electronics problems in satellites and other machinery. Discovered in 1912, many things about cosmic rays remain a mystery more than a century later. One prime example is exactly where they are coming from. Most scientists suspect their origins are related to supernovas or star explosions, but the challenge is that for many years cosmic ray origins appeared uniform to observatories examining the entire sky. A cosmic ray detected on October 15, 1991, had an energy of 51 joules. That is a single subatomic particle with the energy of a baseball going 100 kilometers per hour. For obvious reasons, it was dubbed the particle, but primary cosmic rays like these don't make it down to Earth's surface. Instead, they collide with their molecules around 25 kilometers above the ground and create new particles. Like ions, these collide and decay into other particles like neutrons, protons, muons, electrons, positrons and photons, which in turn collide with other air molecules in one long cascade. So from a single primary cosmic ray comes a shower of particles streaming towards the Earth. It is one of these particles that investigators suspect struck a transistor in a computer in Belgium, flipping the 13th bit from a 0 to a 1 and giving Marie individual 4096 extra votes. These cosmic rays are not only flipping characters on Earth. On October 7, 2008, an Airbus A330 took off from Singapore to Perth. Just over 3 hours into the flight, the plane suddenly pitched down, diving 200 meters. In 20 seconds, inside the plane, everyone experienced negative 0.8 Gs of acceleration. Even the pilot said it would have felt like the plane had flipped over. The G-force was enough to lift them both out of the seat and push them forward as well. Minutes later, the plane dropped another 120 meters. After investigation, they found that it was not their fault. It happened because cosmic rays flipped the plane's computer's bit among 32 bits. Thus, It resulted change in the altitude system, and that plane acted like that. Unfortunately, many passengers got injured by this incident. As these radiations are coming straight from space or universe, it clearly shows that using computer in space won't be a favorable opportunity. Space is full of radiations and cosmic rays. Certainly, these will affect the computer RAM and memory. Although our world is fully dependent on computers, it seems computer is totally unwelcomed at space. Let us know about your thoughts in the comments section. And remember, next time when you see any glitch when you are playing games, don't blame your computer. It might be the cosmic rays.